What's up, guys? This is Coach Cam. Today we're going to be going over this research paper that gets cited for why people are supposed to be choosing lengthened-biased muscle building exercises to build more muscle than I guess just any regular exercise that you can choose from in a gym. This research paper is titled Regional Hypertrophy, the Effect of Exercises at Long and Short Muscle Lengths in Recreationally Trained Women. So the aim of this study was to analyze the role of exercises resistance profile in regional hypertrophy. 38 healthy women completed a 9-week resistance training program consisting of either 4 sets of 12 repetitions to volitional failure using either inclined bicep curls or preacher curls. 3 times per week, 4 sets of 12. Pre and post intervention muscle thickness was measured. Scan acquisition sites were determined by measuring 50%, 60%, and 70% of the distance between the posterior crest of the acromion and the olecranon. So basically they measured on the arm 50%, 60, and 70 down the bicep length to see if they could get more muscle growth in a certain area of the biceps or if they would all grow the same. So a lot of people have been citing this study. Not a lot of people have really been reading it or applying it correctly. So let's go through this study. Let's see what they found, how they found it, and what are kind of the takeaways from this. When you read this study, I've already read it, but we're gonna glance over straight to the participants. They're women, 38 women between 18 and 45 years old. Here we go, 2 different groups. The incline curl group completed 9 weeks training, 4 sets of 12, 3 times per week, performing each set to muscular failure. Okay, so the abstract said volitional failure. Now they're saying muscular failure. Incline bicep curls consisted of performing bicep curls with a dumbbell while lying supine on a bench with 45-degree inclination. The exercise began with the forearm perpendicular to the floor, ended with the elbow reached at least 90 degrees angle, never going beyond 110. Participants in the preacher curl group completed the same training protocol but performed the preacher bicep curl instead of the inclined bicep curl. The preacher bicep curl consisted of performing bicep curls with a dumbbell on a Scott bench. The exercise began with the forearm parallel to the floor or slightly below and ended when the forearm formed a 75-degree angle with the floor, never reaching a position perpendicular to the floor. Participants in both groups were requested to keep the hand always completely supinated to avoid the potential impact that the forearm flexors has on the recruitment of the elbow flexors. All right, guys, so I'm going to show you the exercises they did so we can go over the movement and see if that could have affected their results. The first exercise is a dumbbell incline curl with a bench at 45 degrees. The participants had to have their arms completely straight at the bottom, just like this. Then they had to curl above 90 degrees, so right here at least. And then they had to go straight. If you look at this movement, there is no tension at the biceps at all at the bottom of this movement. It's just passively hanging here. When we read further, we will see the tempo was as fast as possible up and 2 seconds down. So here's an example of how that would look. Let's go over the preacher curl. When it comes to the preacher curl, I'm not sure if they did both arms at the same time or one arm at a time. It wasn't very clear through the research paper. Let me show you what the preacher curl looked like that they talked about in their study. They said that the arm never went past parallel to the floor. So they only went down about right here, and then it never was fully vertical perpendicular, right? So they went back up about here. So this was their range of motion for their preacher curls. It was right here and right here. Does that make sense? It's kind of like a half rep, really, right? Notice how with this, there is tension on the muscle the entire time. Especially right here. There's a lot of tension, and then as you curl it, the tension drops off. And they made sure to never put the dumbbell vertical, or else there's no tension at all. So this exercise, they were able to keep tension the entire time because they only went right before the tension disappears. Important. Hopefully by now you guys can see that there's some big differences in how the exercises were performed and the resistance curves of the exercise. However, this was the whole point of the study, was to see if the resistance curves actually made a difference. As you continue to read, you will see here that they said they want them to perform the concentric portion as fast as possible. They want them to perform the eccentric with 2 seconds lowering. They said that that was to increase time under tension, that was important to them. So that was the way they chose to increase kind of the time that the muscle was under load. Personally, I think that's quite fast for the movement. And then, moving the weight up as fast as possible. When you're doing that incline curl that we just went over, really there's so much tension at the top that you're gonna drop immediately. You're not gonna hold that, right? So you barely get it there and then you get the drop. And then you go back to where there's no tension. So you can see performing that as fast as possible, it's harder to do. It's harder to keep the muscle under tension when you have to keep lowering it back to where there's no tension at all. And then it's harder to get to the top when there's 100% of the load weighing on the biceps at the top of the movement. So that exercise is harder to get the most out of compared to the preacher curl, where they had constant tension the entire exercise. And they were doing like basically half reps, almost quarter reps really. So you could see how you could push yourself harder with the preacher curl. You can get more stimulus from the preacher curl, not because it's lengthened bias, but because it has consistent tension. They should have also measured just a standing cable curl, right? Because there's tension across the entire biceps throughout the entire movement pattern of a cable curl. So I would like to see that in the next research study. As we keep reading, we're going to get to the results. So the incline curl started out at 50% of their biceps was measuring at 2.19 centimeters muscle thickness, and then post 2.24. The 60 went from 2.3 to 2.41. The 70 went from 2.74 to 2.81. So in the incline dumbbell curl, they did improve. Let me do some quick math here. So it's basically 0.07 something. So that one increased by average about 0.07 across the entire 50, 60, and 70% distances that they measured. Next is the preacher curl. When you add up the results, it increases from the preacher curl, it was about 0.2. So you have 0.07 for incline curls and 0.2 for preacher curls. So they saw triple the growth, close to triple the growth using preacher curl compared to incline curls. That's huge. There could be something off with the measurements, but let's go ahead and look down at the arc of the exercise. So the A, B, and C here, you can see how there's no tension at the bottom of the incline curl. And then they finish and there's 100% tension. And then they drop back down. The preacher curl kept tension the entire time. Why is nobody talking about this? Why is everyone saying lengthened bias means more muscle growth? No, it's using an exercise properly, keeping the muscle under load so that you can recruit it, stimulate it, and exhaust it. That is how you train muscle fibers. So the person doing preacher curls, their exercise, and really it's the way they performed it, gave them a better advantage to deeper inroad and target the biceps muscle. The preacher curl saw more growth all the way around. They saw more growth. They just saw a little bit more also at the furthest point on the biceps, the 70% range mark that they were measuring at. And that was statistically significant. So now that's all anyone's talking about, is that you can grow more muscle in this region because of the increases that they found based on the exercise, stressing that region more. Problems with that. So, well, first I'll say this. It could be true. It could be true that certain exercises bias certain areas of your muscle. But what about an exercise that biases the muscle, the entire range of motion? Like I mentioned earlier, a cable curl, where the same weight on the stack is pressing resistance against your biceps the entire time. What bias would that be? What area of the muscle would grow with that? Is the muscle only going to be stronger in this little segment of the movement now? Is it not going to be stronger all the way around? So, there's some questions that come along with a finding like this. Anyway, when you get down to their conclusion, you find here, their conclusion says, the study shows that regional hypertrophy is affected by the resistance profile of an exercise. This means that different regions of a muscle will grow in response to exercises that place the highest difficulty in a particular point of the range of motion. In particular, our results show the distal region of the arm grows in response to the exercises that place the highest amount of strain in the range of motion in which the arm muscles are more elongated, but not in those that place the greatest strain when the arm flexors are shortened. According to the results of the study, the resistance profile of any exercise changes the manner in which involved muscles grow. That's kind of a stretch, guys. They're kind of embellishing this a little bit. For example, when aiming to increase size of the elbow flexors in the part that is closest to the elbow, using exercises which the highest strains pose when muscles are elongated seems to be the best option. This is key in sports such as bodybuilding, where shape, size, and symmetry of muscles are evaluated in competition. So that would be cool. I kind of think that these participants saw muscle growth, right? And I think that their muscle as a whole grew, and that area may have been needing more growth. How can you really say that your muscle is going to put on more tissue in a certain spot when the fibers run this way? You have different genetics. Could it be that these people just had small biceps and they got more growth and it just so happened to grow toward the bottom? It's possible. I just think, when you publish a research study, you want to find something new. You want to find something exciting. That's why you publish it. That's why it gets passed around, because it was exciting. And I think that these authors really wanted to find something exciting, and then that they did. They made sure to post it like this, and then really kind of puff it up a little bit in their conclusions, as if every single exercise is going to place a different type of hypertrophy on certain areas of your muscle. I'm not saying it's not impossible. It very well could. But should we be completely changing our entire exercise programs to try to get certain hypertrophy of certain regions of muscles when people who are in the gym, the vast majority of them, need muscle everywhere? And on top of that, the application that people are making is not, it's going to grow the distal part of my biceps. They're saying it's going to grow more muscle, period, which is not the conclusion that these researchers found, because the other growth that was found was not statistically significant. There was some, but it's not enough to say without a doubt that the reason that they grew was because of the exercise resistance profile. Anyway, hopefully you guys can take something away from this study, that just because you find a study that says one thing doesn't mean you can blanket apply it to everything. And they very well did find more biceps growth at the bottom. However, the exercise had more tension overall, and they were able to push it harder overall. So in my opinion, that is why they got more growth. Whereas the other group doing the incline curls, they were chilling at the bottom with no tension, right? Their muscles were getting a break between reps. Whereas the other exercise, if you did, just think of it. If you did the protocol of as fast as possible concentric, 2-second eccentric, on your preacher curl, you're starting here, 1, 2, 1, 2, 1, 2. See how there's less momentum, less acceleration. 1, 2, 1, 2. Whereas down here, There's no tension at the bottom. You're accelerating it. You're swinging it up because you can't hold it at the top because it's too much weight. They're forcing them to use too much weight. They said if you're getting more than 12 reps, you need to add weight. And then they said if it's too big of a jump to add to the next dumbbell at your gym, then you're gonna need to just go for higher reps. So they basically had them train between 8 to 18 reps to failure, but they weren't in the gym with them. They don't know how their reps look. They don't know the speed that they actually did. They had them go off and perform this on their own. So really, there's a lot of holes in this research paper that nobody's talking about. And I just want you guys to be better equipped to better understand the research and understand that there are some major flaws to research studies. They're not perfect. Researchers are trying to find something new, so they keep researching even at the expense of, understanding basic principles of resistance training. Key takeaways: should we change our exercises to try to get this lengthened bias situation? No, don't do that. Do not start revamping all your exercises based on if they stretch your muscle in a shorter position, length of position. Train hard. Keep tension on your muscles throughout the entire range of motion in any position of all your exercises. That is your best way to grow the entire muscle and to take the set to failure. Who knows exactly how these people's sets were actually performed? That's how they were instructed to do it. But anyway, this is Coach Cam. Go ahead and like the video, leave a comment down below, message me for coaching, and let's build each other up. Let's grow, let's learn from research, but let's also not blindly believe every study and every headline that we see. So thank you guys so much for watching.